Hello everyone, welcome to my video and welcome to the second part of making a handheld game console from scratch series. So in this video we are going to continue with our DIY handheld gaming console project. So last time we left off somewhere over here where we were able to control a tiny game object on the screen, on our screen, which is SSD 1306 solid display. We were able to move a tiny rectangle on screen in 4 directions, which is left, right, up and down. And we had also learned about buttons, setting up our environment, which board to use, which is Raspberry Pi Pico, how to set it up, and all sorts of things like that. First thing what I'm going to do in this video is restructure this project. Right now it's just a single file which is called monoretro.ino, and while a single file is good for getting started with the project or creating a test project, it has lots of cons and it's not suitable for bigger projects, or rather it's not scalable at all. So what we are going to do is we are going to restructure this project in such a way that all our games, like for example we are going to make 2 games as a part of this series, Space Invaders and Pongs. Space Invaders and Pong should be able to live within their own files, right? So we will have one code file for Space Invader, one for Pong. They will have their individual header files, and those header files will get imported into monoretro.ino and we'll be able to play our game. So as I mentioned in my previous video, Arduino is just an extension of C++. So whatever we could do in C++ with header files and stuff, you could do here as well, and whatever you can do in normal C code you can do in Arduino as well. So that's the first thing that I'm going to do. Let's restructure this project and then we'll start with making the first game, which is Space Invaders. So yeah, let's get started. Now I'm going to create a header file called common.h. So all the constants that are common to both the games and all the constants and all the objects that are common to the entire Monoretro project will reside in this common.h. So this common.h can be used by either of our games as well as monoretro.h, monoretro.ino, and this will have things which will not be specific to either of the games, right? Let's start by adding the include guards, which is if and def common h hash define common h. So the first thing that I'm going to do, that I'm going to move here, is the display initialization. So for that, first I'll move the Adafruit display library and its dependencies here. So this is the initialization part. I'm going to move this as well to here, and let's rename it to mono display, since we are anyways calling it Monoretro. The next thing that I'm going to do is things like the screen width and screen height. Both our Space Invaders and Pong are going to use the same resolution for screen, so let's move that here as well. Define screen height, screen width as 128 and screen height as 64. Also, the other thing that I'm going to do is, since in both the games the meaning of the buttons will remain the same, like left button, right button, up and down button, so let's move those constants here as well, and instead of using constant variables, I'm going to define them as macro. So let's define left as 6, hash define right as 7. So the same numerics that I had assigned earlier to these buttons. Hash define down as 8. That's it, and let's just move this below the macro definitions, right? And now what we'll do is, in monoretro.ino we can simply include common.h and get rid of all these things. And what else we can do is we can rename our display to mono display. The other thing we need to do is update the pin initializations to use the macros. This will be right, this will be up, and this will be down. Since now we have seen how the logo of Adafruit looks like, so I'll get rid of that. So instead of delaying for 1 second, I'm simply going to do a, so first let's change this to mono display. I'm simply going to do a clear display. So this will simply remove the logo from the screen in a blink of an eye, right? Not even a blink of an eye, even faster than that. I'm keeping the pin initializations in the setup of monoretro.ino so that we don't have to do it again and again in our individual games. And also the error printing, I'm keeping it inside the setup of monoretro.ino. So now that's pretty much it for as of now for common.h. Next, what I'm going to do is I'll start with the header file of Space Invaders. So actually let's create two files. One is spaceinvaders.h, where the Space Invaders header will reside, and the actual code file where the game code will reside, I'll call it spaceinvaders.ino. So now what I want to do is things like this player structure, this input processing function, I want to move them to the individual game files. Let's start by first let's add the guards, and the first thing that I'm going to move here is this player struct definition. So let's move it here. And the other things that I'm going to create here is certain functions. The first one being void space invaders underscore setup, void space invaders update, and void space invaders render. So all the initializations, the game object creations, variable initializations that we want to do specifically for Space Invaders will reside in Space Invaders setup. All the game environment updates on after processing user inputs will reside in Space Invaders update, and finally Space Invaders render will render the game objects onto screen, right? We'll be defining these functions in spaceinvaders.ino. So now what I'm going to do is in spaceinvaders.ino, I'm going to include common.h, I'm going to include spaceinvaders.h, and the first thing that I'll move here is the player definition. Now this player will be in future this player will be going to be the tank on the screen, shoots at the aliens, right? And now we'll move process input because we'll be using this function to process the input for Space Invaders to spaceinvaders.ino, and once again we'll change these left, right, up and down, right? And apart from this, we'll create a few more functions. One is void space invaders update. So we are defining the Space Invaders update that we created in the header file, and as of now inside Space Invaders update we are just going to call process input. And we'll also create a void space invaders. Actually we can copy it from Monoretro. So this render function, we'll remove it from here and we will put it here. So now we'll simply call it Space Invaders render. So it's the same thing that we were doing in monoretro.ino. Now just we are making it a bit better in structure. In monoretro.ino, I'm going to include spaceinvaders.h and in loop, I'm going to use the functions that we just now created. Space invaders update and space invaders render. One more function we'll be defining in space invaders.ino, but we won't be populating it right now. We won't be creating the body of it fully. Is void space invaders setup. But soon we'll make use of this function. So that's pretty much it. We created one common header file where we have all the common constants and initializations like mono display module, the screen width and height, the all our button constants, right? So we are using it here. So here in this monoretro.ino, now we are using mono display, which we created in common.h. We are initializing all our pins and we are getting rid of the label, the Adafruit label. And in the loop functions, we are simply calling the space invaders header update and render functions. So let's see. Yep, so the update is for processing input and the render is for rendering this thing. So let's quickly compile and see if we have caused any regression in the process of refactoring. Looks like we have an issue. So what we want to do is, in space invaders here, we are going to rename it to mono display, right? And in monoretro.ino, let's check once again. Yep, so as you see, it uploaded the code without any issue. And if you check this on the board, it will be exactly same as what we did earlier. So we will have a tiny rectangle on the screen which will be able to control and move up and down, left and right using the 4 buttons. So functionally nothing we have changed. The output is completely the same, but our project is way better structured right now. We have got a game specific header file, a game specific code file, and we are using both of those in the entry point file, which is monoretro.ino. So now it will be very easy for us to modularize the space invaders code separately from the other game, that is Pong, which we are going to create. Okay, so before moving further with coding our space invaders game, something very important and interesting we need to understand is how are we going to print or paint the sprites that we will be using in our game onto our display module. So sprites are nothing but images that we see in our game world and which we can control and move. So they are basically, sprites are basically like the skin of a game objects which we can move here and there inside a game. In a usual game framework, every game framework supports loading images into the memory which are then used as sprite. For example, in normal game engines or game frameworks like your Lua's Love game engine or the Raylib game engine or Godot, all game engines have or game libraries have a feature to load images like PNG, GIFs or JPEGs into memory and use them in your game. But in this case we don't have such support. So how we can draw sprites onto screen rather than just working with rectangles or squares or basic shapes. So in this case what we are going to use is something called bitmaps. So bitmaps are basically maps or arrays of bits. So the bits in this case, since it's a monochrome display with where color can only be white or black, our work is way easier than normal real world bitmaps which needs to support multiple colors. We in this case need to only support black or white, right? So what we are going to do is we are going to represent the sprites as a map of bits, and each bit can either be 0 or 1. So 1 means that pixel needs to be painted white, and 0 means we don't paint that pixel. So in this way we are going to display or use sprites in our game. So let's understand how we can use a bitmap in Arduino, or how we can use a bitmap to print our sprites on or display our sprites on to our display. Okay, so let's start with designing something simple. We'll start with designing the tank or our player that moves left or right on the on the screen, right? Let's start with the tank. So how I want my tank to look like is something like this. So it should be like so. Again, remember our background, our screen background is black, and whatever we draw on it is using white, right? But however, here, since my background is white, I am drawing the objects using black. So when we will be painting on screen, it will just be the reverse. So this shading means the areas which I am shading, so these are the areas that will be lit on the screen for this particular game object or this sprite, which is the tank. And then I want the bullets, something like this to come out of this tank while we are hitting the enemies. So this is our basic tank, more like two staircases fused together. Pretty simple. So if I want to convert it into a bitmap, I will be using a 8x4 bitmap for my game. If I draw a map, so it's more like a grid. So 1, 2 and 3. So 4 rows, or rather I should call it a 4x8 bitmap. 4 rows cross 8 columns. So 1, 2, 3, 4, 5, 6, 7, 8. So it's a 4x8 grid. What I can do is I can make this 3 0 1 1 0 0 0, another 1 1 0 0 0 0 0 0, and finally 0 0 1 1 1 1 1 1, and the last layer can be all ones. So if you see, we have got, just imagine these portions will be painted white and the remaining will be painted black, since that's the background color. So that is a tank. Now the thing that we need to understand is, let's say I want to print or display this tank at a position called, so again, since it's a bitmap, so this entire map is essentially our bitmap. Although there is nothing here, so the zeros are means we are not painting anything over here, but still they are part of the bitmap. So we cannot say that this portion is not a part, or the portions with all zeros are not a part of the bitmap. That's not the case. The entire rectangle, the entire 4x8 grid is our bitmap. The origin of this sprite will be, as we discussed, we will consider it to be the top left corner. So this will be our pos x, pos y. When we will be defining, or when we will be displaying this object, or we will want to move it, we will continuously need to update pos x, pos y, and relative to this pos x and pos y, we need to print this entire, we need to display this entire bitmap on the screen. So let's see how we can do this. One easy thing we can do is we can start scanning the entire bitmap, row by row and column by column. So for first row we scan all the columns, for second row we scan all the columns, and like that. And whenever we see 1, we turn that pixel at that position on, or we display that pixel as white. So what we can do is we can use a loop for row equal to 0, row less than 4, since it's 4x8, row plus plus, and inside that we can have another loop which is call equal to 0, call less than 8, call for column, call plus plus. And now what we need to check is, we are storing this bitmap in a array, in a 2-dimensional array. Let's call it tank. What we can, or let's call it as of now TB, tank bitmap. So now if TB row column equal to 1, only then what we'll do is draw that particular pixel. So we will draw the pixel at that particular point as white. What we'll do is, now remember the pixel that we want to draw is located at this row comma column but relative to this pos x comma pos y, right? So the pixel that is being pointed, or the pixel that is being implied by this row and this column, is relative to this position pos x comma pos y. So we cannot just draw the pixel that's located at this row and column, because then we will always be painting the same pixel. So we want to paint the pixel at this row and column relative to this position. So for that, what we can do is we will simply add pos x with the column, and this becomes the x coordinate. How this becomes the x coordinate? Remember, the column gives you the x values. The column is basically along the x direction, so the column goes this way, and this also is the x. And remember, rows go this way, rows go this way, and so this is also the y. So we will draw at pos x plus col and pos y plus row. And that's pretty much it. And that's how we can draw a bitmap at a given pos x comma pos y, or a given x comma y coordinate, using this simple procedure, which will scan the bitmap, see which bit is turned on, and display only that pixel relative to the given position of the top left corner. So let's try to see how we can code this, or how we can display bitmap using this procedure on our screen. So before that, let's make some tiny changes. Instead of calling this player, I am going to call it tank. And what I'm going to do is I'm going to give this player some more properties. We already have pos x, pos y, speed, height and width, which is good. I'm going to give it another property which is called alive. This will just help us to keep track of whether the player has been hit or not. And now I'm just going to format it a bit so that it is easier to understand. I'll make its x coordinate as the center, y towards the bottom part of the screen, width is 8, and dot height is 2, actually 4. Remember that we are going to use a 4x8 bitmap, so 4 rows and 8 columns, so that translates here to 8 pixels as width and height as 4 pixels. We want to keep it alive as of now, and I'll increase the speed to 2. So that's a new tank or player structure. I'm going to call this as tank everywhere. Hopefully I've replaced everywhere. Anyway, we are going to change this, but still. Okay. Now let's create our bitmap. So I'll create a constant 2D array of type unsigned integer 8, and I'm using unsigned integer 8 because we are just using, like, we don't need a int for this, we are just storing zeros and ones. And the other thing that I'll do is in space invaders.ino, I will also include std int.h, and let's define our tank bitmap. It's 4 rows cross 8 columns, and as we discussed, it will be 0 0 0 1 1 0 0 0, then pretty much the same row once again, right? Then we will have 0 1 1 1 1. But all will be ones. So now we have our bitmap for the tank. Before proceeding, what the other thing that I'm going to do is, in our player object, I'm going to change all these ints to uint 8_t. So this is basically unsigned 8-bit type. The reason I'm doing is that we'll never need the entire range of an int, right? The int is much longer than unsigned 8-bit, and we really don't need such a big range. So if you think our screen width is 0 to 127, screen height is 0 to 64, so the positions, the width, nothing can cross 127 or 63. So I'm just going to use uint 8_t is over here. Yeah, this all seems fine. And now finally we can start creating the function which will draw this bitmap as a sprite on the screen. So we'll create a function called draw tank uint 8_t. So this draw tank function, it will take the position or the coordinates from where we want to start drawing this bitmap. This will basically be the top left corner of the tank or the game object, and relative to this position we are going to draw the entire bitmap. So pos x uint 8_t pos y, and now we are going to create that loop. Row in size row equal to 0, row less than 4, row plus plus for size t. So we are going row by row and column by column. Now we do the check. If tank bitmap row column is 1, then monodisplay dot drop pixel pos x plus pos x plus column pos y plus row, and ssd 1306 underscore inverse. That's a tiny function there which will take care of drawing the bitmap at a given position on the screen. So now all we need to do is, instead of drawing this rectangle, we will call our draw tank and we will invoke it with pos x and pos y. Yup, and that's it. So let's try to run this and see how it looks on our screen. Let's first see if it compiles as expected or not. Okay, looks like I made a typo somewhere. Semicolon here. Let's try to compile once again. some more errors. Okay, so let's check the order. It's width, height, speed, XY alive. Height, speed, so it's width, height, speed, XY alive. So XY should come here, and that hopefully should do it. Let's see. I believe it got compiled. Okay, now let's see how it looks on the board. So as you can see, it's the same old setup, like I have nothing changed in terms of the circuit, but now you can see that it's no more a trivial rectangle, but it's the bitmap that we used in the code, and that's exactly printed on the screen, right? And also it's now towards the bottom of the screen because we want the tank to be at the bottom of the screen, and we want the enemies or the aliens to slowly scroll down towards the player. And now if we try to control the player, we can only move it left and right, and due to boundary checks it won't fly out of the screen. So yeah, this is how we can display sprites on the display module using bitmaps. It's pretty easy doing it this way, and now we can proceed to see how we can draw enemies on the screen which can move left to right and can slowly scroll down towards the player. So first let's see how do we want our aliens to look like. So let's go back to our drawing board. How I am imagining the aliens as is something like this. So again, we'll have to keep it very minimal so that it can fit in our tiny screen. And again, remember, we will have a group of such aliens and not just one, so we'll have to make space for all of them. So let's give the aliens two tiny leg-like things like this. Something like this. It's just a straight line. And let's give them two eyes-like thing. Again, you are free to make your aliens look whatever the way you want them to look like. Then this entire part will be shaded white. I am using black here, but on the screen it will get inverted. So this is how pretty much our alien will look like, and there will be more like this. So again, like we will use a 4 rows cross 8 column bitmap for our alien. So let's convert it into a bitmap. And there we have 8 columns, 2, 3. So what we can do is, how we can represent this alien, we can do something like 1 1 1 1, right? And then 1 1 1 1, another one, another here, and like let's fill this part as well. And now we want our legs, so here one, another one here, and we can fill these two part as well. So now if I see this, how it looks is something like this. That's pretty much like how this one looks. We know how our alien is going to look like, and we can easily create the bitmap. The other thing that I want to show you all right now is the placement of this alien group on the screen. Let's create a new canvas, and so what I'm going to do is I'm going to represent my screen here. Basically I'm going to draw a grid, and in that grid every cell will represent the position of an alien. Now remember, our alien is 8 pixels in width and 4 pixels in height. If it's 8 pixels in width, the maximum number of aliens that the screen can accommodate width-wise across the width is 128 divided by 8, which is 16. So across the width, across the breadth of the screen, we can have 16 aliens. And across the height of the screen, so height is 64 divided by 4, right? Because the height of individual alien is 4. 64 divided by 4 is again 16. So we can have at the max 16 aliens across from left to right and 16 aliens across from top to bottom. Let's do that. So I'm going to draw 16 columns. That's 16 columns. Now let's draw 16 rows. So now we have 16 cross 16 grid. This is 8 pixels and this is 4 pixels. So each grid is 8 cross 4 or 8 pixels width by 4 pixels in height. So now what I'm going to do is I'm going to start from the rightmost edge. So what I'm thinking of is to have a group of 28 aliens, like 7 cross 4, like 7 aliens across the breadth and 4 aliens across the length. The reason I want to have 7 aliens is, remember, each alien's width is 8 pixels. What I want to have is I want to have a gap of 8 pixels between every 2 aliens so that they don't appear to be too much congested on the screen. So I want to have a gap of 8 pixels between 2 aliens across the breadth of the screen, and I want to have a gap of 4 pixels between 2 aliens across the length of the screen. So it's like one alien 8 pixel gap, another alien across the width, and one alien 4 pixel gap, another alien across the length of the screen. This is because the width of the alien is 8 and the height is 4. So that's why we are having equivalent distances across the breadth and the length of the screen. Putting the aliens at the topmost edge of the screen I believe won't look very nice, or at least I feel that putting the aliens at the topmost edge of the screen won't give a very nice effect. So I want to start from a slight offset from the top edge of the screen. So 0 to 3, and this is 4 to 7, and somewhere here it will be the 8th pixel. So I want to start from the 8th pixel. This is where our first alien will be placed. This is again where the second alien will be placed. Third, fourth, fifth, sixth, and seventh. And that I believe should be enough for like 7 aliens should be enough across the breadth, which will give us enough space here to let them move. The next alien in the next row will start 4 pixels down the first row. So it will be here, again here, so this is how the orientation of the aliens will look like on the screen, and they will move as a group, and they will move to left then right, and like that's how they will proceed. From here we can calculate the starting position of the group. The starting position of the group will be at x equal to 24, because 8 plus 8 plus 8, that's 24, and the starting y will be 4 plus 4 equal to 8. So the entire group, the top left corner of this entire group of alien will be x equal to 24 and y equal to 8. And then after drawing every alien, position of the x coordinate of the next alien will simply be x plus 16. Similarly, when we are changing row, it will be just the previous row's aliens y coordinate plus 8, because it's 4 plus 4, right? So in a row we will keep incrementing the x of an alien by 16, and across a column it will be by 8, right? So let's see how we can code this on the screen. So the first thing that we will do is we will create a struct to represent our alien. So let's go back to space invaders.h and let's create a new struct for the aliens. Again, I will be using uint8 to represent all the properties of the aliens. First we will have a position. First we will have the position properties. Then we will have the width, the height, alien type. Okay, so what is alien type? Alien type will just be an integer, and depending on this integer we can use different sprites for the alien, and so different bitmaps for the alien, just to add a variation to the group of alien. But again, in this game I won't be using it. It's something I initially thought of doing, but then I didn't happen to do it. If you want, you can use this alien type. You can, once you start playing with bitmaps, you can design different custom aliens, and depending on this what kind of alien you want to spawn, you can assign a different integer to this alien type. Depending on that integer, you can draw a different alien using a different bitmap. It's just a way of how you can customize your aliens in the future. And as usual, a life property which determines if the alien has been hit by the bullet or not, and we will name it as alien t. And now what I'm going to do is I'm going to create a draw alien function. It will be very similar to the draw tank function. I am keeping these two functions different, but you can very well keep these two functions same and pass the bitmap as a variable, as a function parameter, and use that. So like you can make this draw, you can combine this draw alien and draw tank function into the same function, or you can have a generic draw game object function, which, or draw from bitmap function, where you can pass different parameters like where to start drawing from, which is pos x pos y, and then the bitmap, and then the length and the breadth of the, or the width and the height of the bitmap, and you can make a generic function. But here I'll just go with a separate drawing functions for these separate game objects. Okay, so it will be pretty similar to this one, as I said already. We'll have a size t row equal to 0, row less than 4, row plus plus, all equal to 0, all less than 8, all plus plus. If here we will change the bitmap. Oh, which reminds me, we need to create the alien bitmap first. So let's create the alien bitmap. Const uint 8 underscore t alien bitmap. It's 4 rows across 8 columns. The first row will be something like 0, 0, 1. By the way, this bitmap, you not need to necessarily use a two-dimensional array to represent a bitmap. You can also use strings, right? You can also use a string of length, let's say is 4 cross 8, right? So 4 cross 8 is 32 bits in total. So you can also use a 32 character string to represent this entire bitmap, and you can use the nice shift operator to find out whether it's a 0 or a 1, and you can draw them accordingly. You can also actually use a array, one-dimensional array of 4 8-character strings. Like each 8-character string will contain zeros and ones, and you can use shift operator to find out whether it's a 0 or a 1, and you can also do like that. Or even another approach you can take is you can use a one-dimensional array of 4 elements, where each element is simply a number, and that number's binary should give you the bits. So for example, it's 00111100, so it's basically an 8-bit number, and you can use an unsigned 8-bit to represent it as a number, or you can simply use binary as well, like a binary number as well. So there are lots of ways to represent a bitmap. You can learn more about bitmaps over the internet. This is the approach I decided to follow, but you can follow any approach. Okay, now we have the alien bitmap, and now if alien bitmap row column equal to 1, then mono display dot draw pixel. We'll do same thing, pos x comma pos x plus col. Here we have our draw alien function, and now comes the fun part where we will load the aliens on the screen, or we will draw the group of aliens on the screen. So let's see how we can do that. So we'll do a void draw aliens. Our starting point on the screen for the group of aliens will be 24. We want to keep enough space on the left hand side because initially they will be on the right, then they will move to left, and the other will be pos y. And we will just create a variable to track which alien we are drawing. There will be total of 28 aliens, and then let's start our loop. So this will control the row of the aliens. Row equal to 1, row less than equal to num alien rows. This is a constant I will be defining soon. Rows plus plus. Let's define this. Let's define it here, and this will be 4. Now a cool trick is we don't need to find out what will be the x coordinate of the last alien on the screen across a row. That's because we will be incrementing it by 16, right? We'll be incrementing the x coordinate of every alien by 16 across a row, and when we increment it for the last time after drawing the last alien, it will cross the screen width boundary. So you can do the calculation. We are starting at 24, and if you keep incrementing this by 16 every time, so this will be, now we are at 24, 60 plus 16 will be 40, plus 16 will be 56, and if you keep doing this way, it will be pretty much 24. Like at the 24th position we are drawing the first alien, plus 16 into 6, which is 120. So at 120th position we are drawing the last alien, which is our 7th alien, and once we add 16 with that, it's 136, which is very much beyond our screen. So our limiting condition while processing a row can be when the position x, when the new position x after adding 16 the last time is greater than the screen width. So if I do it here, it will be easier to understand. So I can simply do while pos x less than screen width. We can do alien index equal to spawn alien, which we'll be defining in a moment, pos x comma pos y comma 1. I could have initialized the alien structure and would have created the alien here itself, but I just wanted to put it in a separate function. That way this loop remains clean and not much congested. Let's define the aliens array also, which will store all our aliens so that we can manipulate their positions, keep track of them and things like that. What we'll essentially do is we'll create a aliens array of length 28. Once we have drawn or spawned an alien, what we will next do is increment the pos x, which will decide the x coordinate of the next alien by 16, and we will increase alien index by 1. Once we are done with our row processing, we will reset our pos x to 24, because remember we'll have to get back to the initial position, initial row start position for the next row, and that was 24. And we will also increment pos y. Remember, we want to keep a gap of 4 pixels between every alien in a column, so we will increment pos y, which will be for the next row, by 8, because 4 pixels for the alien and 4 pixels as a gap. And let's now define our spawn alien function. So we will give it a return type of alien t spawn alien. We will give it a posx parameter, pos y, alien type, and we will create a alien from using its alien underscore t structure. Let's assign the posx, pos y, and also let's create some constants. Let's go back to space invaders.h and have some alien constants, primarily things like alien width, which is 8, alien height, which is 4. Let's put all these at the beginning because it's good to put all the macros at the same place. Num alien rows is 4. Oh, we don't need this actually. We'll do a alien speed 1, and num alien as 28. So we have a alien, let's make it alien, yeah, alien rows, alien width, alien height, speed, and total number of aliens. Okay, so width will be alien width. Let's check the alien thing once. Do we have a pos? Yeah, we were missing a pos y. Okay, dot height equal to alien height, dot alien type equal to 1, dot alive equal to 1, because we want the alien to be alive when it gets spawned. Yeah, so this function we will call here, right? And let's use this. Okay, and this is row. So now we have a function which is called load aliens. Okay, my bad, it will be load aliens and not draw aliens, because that's what I have been calling it. We have now got a function called load aliens. So load aliens basically goes row by row and column by column to spawn aliens at the perfect offset across rows and columns, and this uses a utility function called spawn alien. Spawn alien simply creates an instance of the alien from this alien t structure and returns it. We have a draw alien function which draws the alien on the screen using the bitmap. Now what we would want to do is we would want to create a function called start game, because this loading of alien will happen only once in a game, whenever this game starts. To deal with all our startup functions of the game, we will create a function called start game, and in that start game function we will call only one function, and that is load aliens. And this start game function we will call from setup. And finally what we are going to do is we are going to call this space invaders setup function from Monoretro's setup. Now the final thing that we need to do is we will go into the render function, and before drawing their tank, what we'll do is for size, now we don't need to do any sort of row or column calculation. We have all the aliens stored in the alien array. We will create a loop B. Oh, my bad. Right. And ideally what we should be doing is we should be first checking whether the alien is alive or not. Same thing we should be doing for the tank, but now I'll just let it go since we haven't introduced the bullet and the firing system right now. So when we will do that, we will need to check first whether the alien or the tank is alive before drawing it. So right now I'll just simply draw it. Draw alien, aliens, alien index dot posits, aliens, alien index dot pos y. Yeah, that's it. And yep, that should draw all our aliens on the screen. Okay, that's pretty much it. So now let's upload it to our board. Okay, we have got a few issues. Okay, it's a typo, I believe. Here. Okay, let's compile once again. Okay, so it's in line 46. Let's see what's happening on line 46. 62, there is an issue. Let's try to compile again. Looks like it got compiled without any further issues. Okay, so let's see now how it looks on the board. Okay, so once again, nothing changed with respect to the circuit and the connections, but now on a screen we have the group of aliens. You can also see that the bitmap has been mapped properly on the screen, and the aliens have the design that we implemented via the bitmap and the code, and we have the tank at its usual position. We have total 28 aliens, like 7 per row and 4 per column. Okay, so now we have our group of alien printed on the screen, but they are pretty much static, and what we are going to do now is make them move on the screen from left to right and right to left, and also move them down by 1 unit every time they hit the left edge of the screen. So for that, now let's start by creating a function that allows us to update the position of the aliens on the screen. For that, I will be creating a function called update alien positions, and I will create a flag which is called update alien direction equal to 0. When this alien direction becomes 1, it means we need to change the direction of the aliens. It means it has hit either the left edge or the right edge, and we need to update the direction of their movement. So before we continue further with this function, let's create a variable called alien direction, and what it will initially store is it will store -1. So -1 represents moving left and +1 represents moving right. Initially our group of aliens is towards the rightmost edge of the screen, so at the beginning they should start moving left. So that's why alien direction is -1. Now coming back to our update function, now let's create a loop. Zero. Okay, and for all the aliens, what we are going to do is we are going to update their x position, x coordinate. We are going to increment their x coordinate by alien speed multiplied by alien direction. I'll just explain in a moment why we did this. And finally what we are going to check is if alien index.posx equal to 0, that is we are hitting the left edge of the screen, or if alien index dot pos x plus alien width greater than equal to screen width, which means we are hitting the rightmost edge of the screen, what we do is we update our alien direction flag to be 1, and depending on whether update alien direction flag has been set or not, we update the alien direction variable. Basically we update it by multiplying it with -1. So just this much of the code will take care of the left and right movement of the aliens. So let's understand what we did here. For every alien in the group of aliens, we first updated its position, the x coordinate of its position, by the alien speed multiplied by alien direction. Right now let's say alien speed is 1. If we multiply it with alien direction, which is currently set to -1, so basically we are decrementing it the x coordinate of its position by 1 every time, which means they start moving towards left. Remember, decrementing the x coordinate of a object on screen means moving it towards left. What happens now here is the group of aliens, all the aliens start moving towards left. Once they hit the left edge of the screen, its x coordinate becomes 0, and what happens at that time is we check if it has hit the left edge, we update the alien direction flag to 1, which means we need to change the direction. And in this line, in line 75, we simply check if update direction is true, then we update alien direction from -1 to 1. We simply multiply it with -1 and it becomes 1. So next time when we update the position of the aliens in the next iteration of the game loop, this time instead of decrementing 1 from the x coordinates of the alien positions, we increase its x coordinate by 1, and as a result of which it starts moving towards the right hand side. So then we keep incrementing the x coordinate of the alien positions by 1 until and unless it reaches the rightmost edge of the screen, or rather the rightmost edge of the alien hits the right edge of the screen. The top right corner of a game object is equal to its x coordinate plus the width of its body, right? What happens when the right edge of the alien or any game object hits the right edge of the screen? The x coordinate of its top right corner will become greater than or equal to screen width. So what I am trying to say here is, at this rightmost edge, this corner of the game object, or rather all the pixels that lies on the rightmost edge of the game object, will become greater than or equal to the width of the screen, mostly equal to the width of the screen. And that is when we know that we have hit the right edge of the screen, and we again set the update alien direction flag to 1, and it will start moving towards left. Now one optimization we can do here is, if we go back to our canvas, what we are doing right now is we are checking this boundary case, whether the alien has reached the left edge of the screen or the right edge of the screen for all the aliens in the group, which is a wastage of computation. We don't need to do that, because what we want to essentially detect is whenever any of the aliens belonging to the leftmost column hits the left edge of the screen, it's time to change the direction. And whenever any alien from the rightmost column of the group of aliens, like for example this column, hits the right edge of the screen, we want to change the direction. We don't need essentially to check this boundary condition for every alien in the group. So what we could do is we could somehow try to figure out which is the living alien or the alien which is alive at the leftmost part of the group. That will give us the leftmost alien column, and which alien is alive in the rightmost edge of the group of aliens. That will give us the rightmost column, and then we can perform the boundary check for only those two aliens. We don't need to all the time keep on doing the boundary check for all the aliens. So this is one optimization that we can possibly do in future, but as of now the the cost of this computation is not that visible on the screen, so I would stick to this simple approach of checking the boundary condition for left and right edge hit for all the aliens, right? Now we know how to move the aliens left and right on the screen. Next, what we are going to do is we are going to move the aliens down. For that, I am going to create a flag called move down, and again, this flag doesn't have really any use case in the game context, but it's really helpful while testing. Let's say you want to switch off this move down feature, like you don't want the aliens to move down. Let's say you are testing the shooting feature or something like that, you can simply turn it 0 and prevent the aliens from moving down. Now what we will do is, if we'll check if move down equal to 1 and update alien direction equal to 1 and alien direction equal to 1, then once again we will loop over all the aliens it will be size t, and we'll do pause y plus equal to 1, and that's it. That will take care of moving the aliens down by 1 pixel every time they hit the left edge of the screen. So let's understand how we are doing it. Let's ignore this move down equal to 1 because it will always be 1. We have set it that way. Now whenever update alien direction equal to 1 and alien direction is 1, it means that the group of aliens has hit the left edge of the screen. We know that because update alien direction flag was set to 1 and the current alien direction is 1, which means there has been a transition in alien direction from -1 to 1. So a transition from -1 to 1 means the alien's direction has just now been changed from left to right. Every time at the beginning of this function we always set it to 0. This being 1 means it has been just updated from left to right, and hence we can now move all the aliens down by 1 pixel. And now let's call this function from here just before processing our input. So now you can see that the aliens are moving across the screen from right to left and left to right, and every time they are hitting the left edge they are moving 1 pixel down, right? See how they are continuously moving down whenever they are hitting the left edge of the screen, and slowly they will move out of the screen. So what we essentially want to do is that whenever the aliens touch the level of the player, that is the level of the tank, it's game over for the player, right? And we will have to restart the game. But that's what we will eventually be doing. The goal will be to shoot the aliens down before they reach the level of the player. One interesting thing is that if you are testing it out on your own board, once all the aliens are out of the screen and if you leave it that way, what happens is after some time you will see that again it scrolls back from the top edge of the screen. Like once again it scrolls into the viewing port of the screen from the top edge. This happens because remember how we are using unsigned 8-bit integers for the positions of the player. What happens is its y coordinate of the aliens keeps on increasing, and the moment it goes beyond 255, because the range of 8-bit unsigned type is 0 to 255, once the value crosses the 255 limit, it wraps back to 0, and that's how you will again see the aliens moving down from the top edge of the screen. So let's just see this once again. Let me just unplug my board and plug it once again. You can see once again how it's bouncing off the edges and moving down whenever it's touching the left edge. So yeah, that's it about moving the aliens across the screen. So we have two major functionality of the game now ready. We have a tank, we have the group of aliens. We have figured out how to make them move across the screen. We have figured out how to move them down. Now we know how to draw sprites on the screen. We know what is a bitmap, how to use bitmap to draw sprites on the screen. So for this video, I believe I'll stop at this point. What we are going to do in the next video is we are going to add the shooting system, like we will make the aliens shoot at the tank, and we'll also add the ability to shoot back at the aliens from the tank. And then we will also do things like killing the aliens. We will track if an alien is alive or dead. When an alien has been hit, we will make that alien disappear from the screen and things like that. So we will do all those things in the next video. So yep, thanks a lot for watching this video and see you all soon.